Hello everyone, my name is Dan Stahl and my presentation is going to be on self-driving cars and their implications. So the agenda, I'm going to go over what are self-driving cars, how do they work, history and competitive landscape, challenges to reach full automation, implications and impacts, and discussion questions. So based on the most cited source for driving automation, which is the Society of Automotive Engineers International, there are 6 different levels of driving automation. So levels 0 through 2, those provide driver support. So you are driving and must constantly supervise the vehicle. So in level 0, this provides warnings and momentary assistance. So examples of this would be emergency braking or blind spot warnings. So level 1, this has a single automated system. So it could provide either steering or braking and acceleration support. So an example of this would be lane centering or adaptive cruise control. So level 2, this will have communication between features, such as steering and brake and acceleration. So an example of this would be both lane centering and adaptive cruise control working simultaneously. And levels 3 through 5 are automated driving. So you are not driving, but for most of these, you still have to be engaged. So level 3, this is conditional automation. So the vehicle is driving, but it's under limited conditions. So example of this would be the traffic jam chauffeur. Level 4, this is high automation. So the vehicle performs all driving tasks, but can only be done on known roads, and human override still is an option. Level 5, so this is full automation, so 0 human interactions required. The vehicle is able to perform all driving tasks, and they even think at this point there might not even be a need for a wheel or pedals. A couple of different steps need to happen for the self-driving car to have enough information to be able to drive. So the first is going to be environment data gathering, and this is accomplished through using a variety of sensors as well as imaging process software that detects lane stripes, signs, stoplights, road signs, and other objects. So an example of this will be this picture here, where it's identified different kinds of objects such as vehicles or cyclists or pedestrians. And the companies, they'll have different sorts of sensors that they use. So vision-based cameras, those are used by Tesla. So those provide high resolution images, and this comes at a lower price point than LiDAR. And LiDAR is used by companies like Waymo. So this is light detection and ranging sensors. So it bounces pulses of light off the surroundings. And it has a 360-degree spinning sensor. You can see an example of that in this graph here. And this comes at a much higher price point, and it doesn't perform as well. The vision-based cameras and LiDAR, they do not perform as well under poor weather conditions. And then the real brains behind self-driving cars is going to be the data processing, environment processing, analysis, and action. So once it has the environment data, it can process it with the software, plots a path, and sends instructions to the car's actuators. So this will be the acceleration, braking, and steering. And then there's some other variables that it considers, such as obstacle avoidance algorithms, predictive modeling, and object recognition. So this helps the software follow traffic rules and navigate different kinds of obstacles. So it's accomplished through artificial intelligence, machine learning, and there's also something called a convolutional neural network. And this is a deep learning algorithm that attempts to mimic human behavior using basically understanding an image and then making decisions off that. So the history of self-driving cars goes back a little further than I was expecting. So in 1939, General Motors presented a concept of a driverless car, and this functioned by using a radio-controlled electromagnetic field, and there were different magnetized metal spikes that were embedded in the roadway. And then in the late 80s and 90s, Carnegie Mellon, they began to build a self-driving car, And in 1995, they traveled from Pittsburgh to San Diego. And they did have to control the speed and braking, but otherwise the car controlled the other functions. And then to expedite the development of self-driving cars, DARPA, which is the DoD's research arm, they sponsored a challenge for companies to attempt to navigate 150 miles of desert roadway. However, no car is able to complete the route without human intervention. And then in the mid 2010s, that's when large companies like Google, which is Waymo, and then other companies such as Ford, Mercedes-Benz, BMW began to explore the self-driving technology. So you kind of see this timeline here, and pretty much all the major companies have entered this competition. And another interesting data point I found is regarding California's autonomous vehicle deployment program. So the goal of this is to establish regulations for manufacturers to meet prior to deploying their self-driving cars on the public roads. And these companies, they're required to submit data and to report miles driven, as well as total disengagements from autonomous mode. So this could be due to technology failures or the operator having to take manual control of the vehicle to operate safely. So there's more than 5 companies, but I only pulled the data for the top 5 companies from the program. And as you can see, there's a pretty large variation between the miles per disengagement. So you look at Cruise, they were able to go 95, almost 96,000 miles on average without having to have a disengagement of the autonomous mode. And overall, these top 5 companies, they were able to go about 18,000 miles per disengagement. So I think this gives a pretty good idea of where we're at with self-driving cars. The challenges are going to have to be addressed before self-driving cars can reach full automation. So the first challenge is going to be radar interference. So there's multiple self-driving cars. They're all driving on the same road. Is there any chance that their signals are going to interfere with one another? Another challenge is going to be safe driving in all weather conditions. So it relies heavily on visual information, and weather conditions will play a major impact on the effectiveness of the image quality on the environment data they collect. So for example, will the rain affect visibility of signs, other objects, such as pedestrians, or if there's snow on the ground and it can't see where the lane markings are, how is it going to handle that situation? There's also construction or lane diversions. So the flow of traffic can often change, and these systems rely on GPS to plan their routes. So if the flow of traffic changes, are they going to be able to follow these routes or make changes to them for these unpredictable changes that could occur? And another concern is going to be cybersecurity. So there are millions of lines of code that these self-driving cars use of software, and it's potential a hacker could infiltrate the system and corrupt, damage the code or the entire system. And there's also an artificial intelligence versus emotional intelligence. So driving, there's a lot of consideration of subtle cues or nonverbal communications between pedestrians or looking at body language of other drivers. So is a self-driving car going to be able to pick up on this? And Google says that they've trained cars to recognize cyclists and interpret hand signals, but there are thousands of different types of scenarios that could occur. And probably the best way to address many of these challenges is going to be using virtual modeling and testing. So this will allow creating environments to train and make a more smart and adaptive system that'll overall increase the safety of these self-driving cars. And then a couple of other issues are going to be state and federal regulations. So there's going to be differing state laws, and then it's early in the process, so it's kind of hard to predict where these regulations could go. In Ohio, currently, self-driving cars, they are allowed on the roads, but there's a separate body that handles the regulation of these called Drive Ohio. And the final challenge is going to be who's at fault in a crash involving a self-driving car. So for example, if there's not a driver present Is the manufacturer going to be responsible, or is it going to be the owner of the vehicle? So it is expected that self-driving cars will increase safety as well as lead to less car crash fatalities. So the average number of fatalities per year is usually around 35 to 45,000 in the US, and many of these are caused by impaired driving, which is about 35% of all fatalities are due to impaired driving. You can see in this pie chart here the breakdown of where these different fatalities tend to happen between pedestrians or motorcycles. And then another implication that could occur is reduced congestion. So with 5G and those capabilities that technology will bring, expect that there'll be a faster connection between different systems and cars. They can communicate with each other. There's potential that it could lower congestion. And another issue it could solve is the phantom intersections are created between stop and go traffic. So all these cars could use constant moving speed, and this will help prevent traffic. And then another industry that will probably have big impacts on is freight transportation. So it's expected that it could lead to cost savings up to a 45% decline in transportation costs. So this is about 85 to 125 billion decrease. So you can see this chart here, the total cost of ownership savings expected over time once they hit 2027, which this will be level 4 automation is what this is based off of. You can see a 25% drop in cost. So another industry that could be impacted is going to be delivery services. So the rise of e-commerce has led to huge increase in the number of deliveries. So it's about 12 to 15% of all purchases, as well as increasing same-day delivery options. So right now, 5% of all of Amazon's deliveries are made same day. So expected that could triple over the next 5 years. And then another is going to be the taxi and ride-sharing services. So currently there's robo-taxis, what they're calling them, that are currently operating in San Francisco and Phoenix. And these are conducted by Waymo and Cruise, and these function under limited conditions. And then some other applications that could be used in would be where there's heavy vehicle machinery. So this could be farming, construction, or mining. And then another industry that could be impacted is going to be urban planning. So with the impact of self-driving cars is the design of cities, roads, and parking garages. Are those all going to be affected? Questions. Do you have any experience with self-driving cars? Do you think we'll reach full self-driving automation of level 5? And would you feel comfortable not having any override capability if there weren't steering wheels or brakes? Are there any other carryovers to other industries or impacts that could be caused by this technology? And are there any other potential issues you could foresee? Our references. So thank you, everyone. I hope you enjoyed this presentation. Thank you.